Howdy, howdy. Welcome to lesson 5, where we will officially introduce this concept of slope. Slope is something we've already unofficially been working with. We're just now going to define it and see where it lives when we are talking about linear graphs. When a linear function is graphed, we create a line that has something called a slope. And slope is the number that describes the direction that your line is moving in and the steepness of that line. So when we're talking about direction, we're usually talking about, is it a positive or negative slope? So the one on our screen right here would be a negative, because we can see its motion is heading down. Okay, and the steepness is just how quickly it is moving in a downward direction. All right, it is also often referred to as a rate of change or a growth factor, and it is represented by the variable m. So we are going to start using that variable m today. All right, and if we wanted just a sneak peek, our slope would live, we're looking at the rate of change, just like we did on tables, we're looking at change in y. So how are our y values changing? Divided by our change in x. So that should be familiar. Again, that would be our change in y and our change in x. Should be familiar from our work with tables. All right, whole lot of writing here. But basically there are 4 classifications of slopes. The most typical that we work with are positive slopes or negative slopes. So negative slope is like what we just saw. A positive slope is its inverse. It's like this one right here, where it is moving in an upward direction. We also have something called a zero slope. A zero slope is a constant line that never grows. So it's neither positive where it's moving up, negative where it's moving down. It is just a horizontal line. As x increases, y remains constant. And then we have, lastly, an undefined slope. And this is not a function because we have one input. Let's imagine, we don't even have to imagine, we know that this is where x is 1, so that'd be 2, 3. And when we input 1, not only do we have those 2 particular points there, but we have an indefinite number of points or outputs. So one input with infinite outputs, definitely not a function. So it's a vertical line. As y increases, x remains the same. And its name is undefined for the fact that it's impossible to divide by 0. So if we're looking for a change in y over a change in x, an undefined slope like the one we see here, we would see that as well as as y increases by 1, x increases by 0. And you can't divide by 0. That would just be called undefined. Okay, I like these examples. Go ahead and read them, write them down, pause, take as many notes as you can fit onto your notepad, and then let's move on. We will typically see slope represented as a fraction. Often we talk about that as a rise over run. This is really helpful when you're trying to find it off of a graph. We will also talk about it as a change in y over a change in x. And so even if your slope is a whole number or an integer, we can still express it as a fraction like we saw in the tables. We might say if our slope is 3, if m equals 3, what that means is that is a rise of 3, run of 1. Your numerator in this case then is going to refer to how many units up or down your line is moving from point to point. So a good thing to put in your notes, it's your rise, it's your change in y, and it refers to how many units up or down one point on a line is from another point. Okay, and then your denominator is going to be your run or your change in x, and it will refer to how many points to the left or to the right one point is from another point. And the direction, right or left, will depend on whether or not that slope is a positive or negative. So let's do a couple examples here. I have an example of a positive slope and an example of a negative slope. Let's start with taking a look at this positive slope. So on this graph, if you're not given points, find a couple that are really easily identified, meaning they are right at the intersection of 2 points on your graph. And this graph is super hard to read. Let me put some data on it real quick. All right, there we go. Gotta have a scale, right? All right, so let's start with looking for our rise between these 2 points. And I'm going to start with my bottom point and just count. So I'm going 1, 2, 3, 4 points up. So I would say that my rise here is positive 4. And then let's do our run. So the run is your change in x. So that is 1, 2. Okay, so our rise is 4 over 2. Or I mean our run. So we would say our slope m is 4 over 2. Or we could say that it is 2 over 1 or just 2. And inversely, if we want to start with the top, what we'd look at is, well, now our rise would be down 1, 2, 3, 4. So that would be a rise of negative 4 because we were moving down, and a run of 1, 2, negative 2 because we were moving to the left, which still equals positive 2 over 1 or just positive 2 because a negative divided by a negative is a positive. So either direction you're moving in, if you want to, whichever point you start with, you're going to come up with the same slope. M for this is a positive 2. And that positive 2 is what gives it this positive movement where our values are increasing. All right, negative slope, we can do the same thing. We have these 2 points. And this one you can already kind of see our change in y. Oh, they started with the top point. So let's just write this down. I'm going to use change in y over change in x this time because it really means the same thing as rise over run. But we can see here our change in x, if we start with our top point, is to the right, 1, 2, 3 points. So change in x is a positive 3. And then if we need to find that point, our run or our change in y would be 1, 2, 3, 4, 5, 6 down, so negative 6. And so our slope then, or m, would equal negative 6/3, which is the same as saying negative 2 over 1, or just negative 2. And if I wanted to start at the bottom point instead, I'll do this in a different color. I wanted to start down here and calculate my change in y over change in x. I could easily say, okay, well then my run this time was negative 1, 2, 3. So my change in x is now negative 3. And my change in y is a positive, so moving up 1, 2, 3, 4, 5, 6. So this time we've got a positive up there. Still going to equal negative 2. So in both, no matter which point you start at, your m will remain the same. So let's try this one more time, and this time let's use these 3 distinct steps. Your step 1 is just determine if your slope is positive or negative. And that just means, are your values of x increasing or decreasing? And so in this case, as we move, I can kind of imagine if I have a little bucket of water. Ooh, here comes some art. Careful, guys, there's doing art. And I poured that water on, it would run down. So negative slope, water runs down. Sad. Positive slope, you're climbing a mountain. Happy, depending on who you are, I guess. I might rather have water poured on me than climb a mountain. But that's just me. I digress. Okay. Step 2, you can use any 2 points. So highlight that, underline it. You can use any 2 points on a line, keeping in mind there are infinite points on a line. And you'll calculate the rise and run and express it as a fraction. Any 2 points. And then step 3, you will simplify that fraction if possible. I'm going to show that it really doesn't matter which 2 points you pick. I'm going to start with these 2. I'll start with this point and this point. Set up my change in y over change in x, and then let's calculate it. So I'm going to start from the bottom on this one, and then first I want to calculate my change in y, which is my rise over run. So I'm going to say I'm going up 1, up 2. So my rise is a positive 2. And then let's do my run. I'm going to the left 1, to the left 2, to the left 3. So my change in x, or my run, is -3. So my slope, I would say here, m equals -2/3. Okay, what if I had chosen two different points to work with? What if I had chosen maybe this time the outside two? Okay, and what if this time I started from the top and I worked my way down? Set up my change in y over change in x. So this time I'm starting from the top point. I'm going to say, all right, let's do my rise. It's rise over run. So my rise is down 1, down 2, down 3, down 4. So my change in y was -4. And my change in x is to the right, +1, +2, +3, +4, +5, +6. Which, when I simplify that down, is still -2/3. So my slope is -2/3. You could get real hard on yourself and pick some fancy weird points that you knew for a fact what their value was. Find the slope between them, and it would always end up being -2/3. For this line, that is, sorry. Okay. Next step, you try it. So I gave you 3 different points to work with here. Calculate the slope from the graph, and then check on back and see how you did. Okay, so I went ahead and put 3 different examples up here, all color coordinated. Maybe you found something different. Maybe you chose a different path. Maybe you used all rise over run. Maybe you used all change in y over change in x. As long as you're coming up with m equals -2/3, or our slope is -2/3, then you did it correct. If you're having any troubles with it, come on over and see me and I can walk you through it a little bit more. Otherwise, grab those journal problems and get going. Thanks, y'all.